So I'm going to just start this today with a short review of example 8, where it talks about the height above the ground of a golf ball depends on time, and it gives us f of t is equal to negative 16t squared plus 80t. And it asks us to factor and find your zeros. So we're going to set this equal to 0, factor it, and we find our zeros here, which is going to be the time that whenever the height is 0 where the ball is on the ground. These are going to be spots on the x-axis as I showed right here, and we know that the vertex is going to be right in the middle of it. So right in the middle of 0 and 5 is 2.5, and that's going to give us our vertex. So up here I might have in this spot right over here put 2.5 and calculate what that's going to be, because it is our vertex. Now I'm going to try and show you how to do this on your calculator. So here we go. So now when using your calculator, if you want to calculate, you can always use this right here, this calculator. I, however, like to go to Home and then do a new document and then add a calculator in there. So what I want to do is I want to evaluate negative 16t squared plus 80t. So I'm going to put in a negative, and I want a negative 16t, well, here's our t down here, t squared. And while I'm talking about this, remember that this sign right here is the negative, whereas this one is the subtract. So negative should have been what you're going to be using. Now I want to add, so I'm going to plus, and then 80, and then t. So we'll put that in. Now what I want to do is I want to evaluate that for 2.5. So to do this, I'm going to show you a cool little trick. What I'm going to hit is hit the control button, the blue button, control, and then hit the equal sign just underneath it, equal. And then it gives me these choices. And I'm going to use this bar right there. We've used it before in another context totally, and it means such that. So use the such that bar, and then we're going to say that we want t. So again, I'm going to put t, and then use the equal, which is right underneath the control, equals, and then we're going to put in 2.5 and then enter it. And that gives us the answer of 100. So our vertex then is going to be 2.5, 100. Now if I wanted to do another one, I'm going to use this up arrow. Again, another nifty trick. You could always type it in again, but I'm going to use the up arrow once, twice, and you see now it's highlighting what I used, and then I'm going to push enter, and it retypes the whole thing, except now I want to get rid of the 2.5 maybe, and so I want to delete the 2.5, and maybe let's put in a 6 and just see what happens there, and enter, and I get negative 96. No, we don't want to improve our performance. So hopefully that gives you an idea of how you can calculate a lot of different points when you have these equations that way. All right, so next we're going to use our calculator for these problems. We're going to, example 5, there's a couple of these there, height and feet above the ground of an arrow after it's shot can be modeled by this equation. So y represents the height and t represents the time. Can the arrow pass over a tree that is 68 feet tall? Explain why or why not. Now we're going to use our calculator to do this. So I'm going to go back to the calculator, and this time I want to graph. So I am going to hit what I want. You see up right here underneath the on, it says plus page. I'm going to add a page, so I'm going to hit control and hit the dot button. And that's going to give me an opportunity to add a page, and I'm going to add a graph. And now I'm going to type in negative 16t squared. So we've got a negative 16t to the second, then plus 62t, and then plus 4. You might notice that I made the mistake and have an X in the middle of that problem. That should also be a T as well. Oh, one more problem. When I graph this, it is not going to work, because what do you notice about my axes? What's this one named right here? It's named X. And if I graph T's, it's not going to recognize it. So I need to come back. I need to change those to X's. So I went X, and that was a plus. And then plus, oops, negative 16. I kind of went crazy here on this. So it's not doing this. So it's going to be raised to the second power. Then we're going to have plus. Okay, just delete this right there. So I'll delete that. So negative 16x squared, good, plus 62, and I want this to be an x. All right, if you lose it like I did just then, you want to come over and hit the tab button. So write that down. To get back your equation, you're going to hit tab. And oh, it did go completely? Yes, it did. Okay, well, that's happy. All right, so let's start over again. So negative 16x squared plus 62x plus 4. And I'm going to enter it. So enter. Oh, and I kind of see that blue line there, and I know it's going to be a parabola, but I can't see the top of it. Now, I'm going to use kind of as a hint that this talks about an arrow passing over a tree that's 68 feet tall. So maybe I need, rather than going up to just 10, maybe go up to 100. So to do that, I'm going to come here to the menu button, hit menu. Then I have these choices here, view, graph. I'm going to hit window. So hit window, then come over, and then I want to do window settings. It looks like I can see my X values, but I need to change my high value. So I want to change my Y. Let's change it to 100 and see if that does the trick. Sometimes you just have to play around just a little bit. And there we can see it. All right, so we see our parabola. So the question is, will it pass over a tree that's 68 feet tall? So now what I'm going to do is I'm going to hit tab, and that's going to make it show a different equation. And this time I'm going to put in just 68. And that's going to give me a horizontal line through 68. So that's 68 feet high right there. So will my arrow pass over the tree? The answer is no. So for example 6, the height of a small rise in a roller coaster track is modeled by this equation, where x is the distance in feet from a support pole at ground level. Find the height when a person is at the top of the track. So we want to start off, because we really don't know, we want to find, if I want to find the top of the track, I want to find the vertex. So I'm going to first find the zeros. So the height of the rise is going to be 0, and you can see here that I put it into the quadratic formula. I put it into my calculator and entered it, and I got -7. Now I'm going to get one more 0, and I need to do it by finding out what this is when this is a minus. So again, remember that we're going to go use that up button, up, highlight it, enter it, and then come back here, and this time we're going to put in a subtraction and then enter, and we get this time 13. So the other 0 is going to be 13, and we know that our vertex is in the middle, exactly in the middle of those two. So I add -7 plus 13 divided by 2, get 6 divided by 2, and I get 3 for my vertex. So my vertex is 3, and then we need to calculate then what's going to happen right here. So we're going to use, we're going to put this in and evaluate it with a such that. All right, so I entered my equation in. Then we're going to do the such that. So hit the control and the equals. Use that straight bar, that such that. And then this time our variable's x. Well, you want to use x is equal to, and our vertex is going to be at 3. So we're going to do x is equal to 3, and we get for our answer 7. And so I'll put our 7 here. So what we're going to say is that after, does it tell us what those are? Find the height when the person is at the top of the track. And it looks like the height of the rise is 7 feet. Now, you weren't supposed to do this, but this is just a real quick picture of what that parabola looks like. And you can see that that high point looks like it's going to be at 7. Let's see. All right, so let's take a look at example 7 and see what we can do here. Dolphin trainers at SeaWorld can use quadratic equations to plan the choreography for their shows. So the quadratic function y equals negative 16x squared plus 20x can be used to model a dolphin's height above the water after x seconds. It says graph this equation in your calculator, fill in the table, and graph the function on the grid below. So let's see what we do here. So I'm going to come over here, and again, I'm going to hit the blue control and then the dock, which gives me the add page. So I'm going to start off with a fresh add a graph. And so we're going to put in here then a negative 16x squared and then plus 20x. And then we're going to have to graph it. Well, there we have it. So we got our graph there. It's showing up just fine. Those dolphins are jumping around 7 feet. So now what we're going to do is we're going to hit the menu. So here's the menu button right here, menu. We're going to come over here to our choices, and we're going to choose a table. And then we'll choose the split screen table. So we get a table over there. So we get some numbers here. One, what we'd really like to know what happens at 0, right? So it looks like at 0, we have 0 feet. And at 1, we have a 4. Then at 2, we go to negative 24. So it's going way off the chart. So we're kind of getting this 0, 0 here. And then when we put in a 1, we're getting something way up here. We're not quite sure if it's the middle or not, because it doesn't look like we know what this is right there. So we don't know where it's crossing the axis to know what the middle of it is. So what we're going to do now is go to menu, and we're going to go to table, and we're going to hit this edit table settings. And maybe we'll go back and start it at 0 again. And this time we're going to put in for our table steps, we're going to put in 0.25 and push OK. So now you can see, you can't really see these, but see this one is 0.5, this is 0.75. So when I have 0.5, so I can then change my chart a little bit. When I've got 0.5, I have a 6. Oh, is it exactly 6? Maybe it is. And when I get 0.75, it looks like I am getting also 6. That kind of bugs me a little bit. Maybe those are rounded off. I don't know. And then at 1, I have a 4. At 1.25, I have a 0. All right, so now let's come back and take a look at that on our chart. So you see I've got mine filled in with those numbers, 0, 0, 0.56, 0.756, 1, 4, and 1.250. And you can see down here that this was labeled in steps of 0.25. So that's what's going to give you the indication that you want to change your table so that it has steps of smaller numbers. So I have a 0, 0. I have 0.5, 6. I have 0.75, 6. Oops, did I go? Yeah, 6. And then I have a 1 is 4. 1, 2, 3, 4. And that's going to mean that 0.25 was, I guess, also 4 right there, because that's even. And then 1.25 is 0. So I need something right in the middle of, it looks like 0.5 and 0.75. So I'll take 0.5 plus 0.75 and divide it by 2 and to find the vertex on that. So again, I'm going to hit Control going to add a page, and this time I'm going to do a calculator, and I'm going to do a fraction.